I'm creating a parametric voltage rail to help reverse engineer iPhone cameras. In part 1, we determined that we need to target a voltage output with a 2% noise tolerance and capable of at least 1.5 amps to be safe. But what about topology? Do we need to go with a DC to DC buck converter or a linear dropout regulator, otherwise known as an LDO? Well, we already know that U2501 is an LDO, and we can see that both the 1.2 and 3 volt rails are using an LDO. But on the other hand, we can see that the 2.8 volt rail is using a buck converter.
What?
So what gives? How would I pick between an LDO or a buck converter? Well, for that, we must know some key characteristics about LDOs and DC to DC buck converters. In general, LDOs have low efficiency but are very stable and simple. On the other hand, DC to DC buck converters are efficient but are noisy, less stable, and have a higher complexity. Meaning, an LDO is a perfect fit as we want a cleaner voltage rail and do not need to worry about heat dissipation and efficiency. So, after some shopping, I landed on the AP7173, which provides up to 1.5 amps and fits exactly within our voltage output range of 1.2 to 3 volts. Perfect. For better control, add a load switch ahead of the LDO so we can turn on the power supply without connecting it to the camera. Finally, we need the ability to measure the current through each rail. This will be covered in part 3. Huge thanks to everyone who left a comment recently. I've added your names to the design. Lastly, if you're interested in collaborating with me and getting access to the open source files, make sure to join the Discord at discord.leadedlab.com.